Engineering conversation and innovation. This is Schulich Connects.
Good morning, everyone, and welcome. My name is Anders Nygren. I'm the Interim Dean of the Schulich School of Engineering. And it's my pleasure to welcome you here this morning to our Schulich Connects event called Reaching New Heights, Propelling the Future of Aerospace Engineering. I'm really delighted to see so many of you join us this morning. Before we get started, I'd like to take a moment to acknowledge that we are gathered this morning on the traditional territories of the peoples of the Treaty 7 region here in southern Alberta. This includes the Blackfoot Confederacy, comprising the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including Chiniki, Bears Paw, and Goodstoney First Nations. And the city of Calgary is also home to Métis Nation of Alberta, Districts 5 and 6. So our topic this morning is aerospace. And engineering is really energizing the aerospace economy in Canada, with Calgary emerging as an economic hub for aerospace innovation. So this growing industry, it's revolutionizing the way we travel, and it's fostering critical collaborations between industry, academia, and the government. And our panel this morning will explore how advancements in aerospace technology are transforming our economy. And they will also discuss challenges and opportunities in creating a sustainable future for aerospace. Before I pass it over to the speakers, some quick logistics. So there will be an opportunity to ask questions later on this morning. There will be a Q&A session towards the end of our program, so please hold any questions you have until then. And at that time, we will have somebody with a microphone that can come to you if you wish to ask a question. So I'd now like to introduce you to Dr. Craig Johansson, today's moderator. So Dr. Johansson completed his PhD at Queen's University, where he studied explosions and pulse detonation engine technology. Sounds kind of scary, Craig. Well, no explosions this morning, I hope. He later worked at the NASA Langley Research Center on high-speed aerodynamics and propulsion using laser diagnostics. And in 2011, we were fortunate to have Dr. Johansson join us here at the University of Calgary to create the AeroCore Research Group, which includes 3 laboratories on numerical modeling, non-intrusive diagnostics, and propulsion. Craig is an entrepreneur, and he's also a co-founder of the University of Calgary Aerospace Network, or UCAN for short. So I'd like to pass things over to Craig now. And Craig will introduce us to the rest of this morning's panel. So welcome again, and Craig, over to you.
Thank you for the introduction, Anders. So while I have the mic, I just wanted to give a 2 minutes thought about my feelings about aerospace. So I think of aerospace as a story of firsts, especially characterized by what happened between 1903 and 1969. So in 1903, we had the Wright brothers, develop the first powered flight. And although it was very short, low altitude, a small duration flight, that really kicked things off. And we went from that flight to powered flight over the Atlantic Ocean to aircraft that had jet turbine technology that could break the sound barrier, to developing rockets that could put satellites into orbit, up to 200 kilometers up, 10 kilometers a second velocity, putting a person in space, and then finally culminating in 1969 to putting a person on the moon. So this really visible, rapid progression of aerospace technology is what people think about in aerospace, and Canada has been a big part of that whole story. Even visibly in Canada with the Avro Aero project, developing the most sophisticated supersonic fighter jet at the time, and then Canadian scientists and engineers working abroad on programs like Apollo or development of the Concorde has been very visible. And people think maybe that 1969 was the peak of aerospace progression, but I think we are actually going into a second aerospace revolution, and certain things happened since 1969 that allowed this to happen. So for example, we had the rapid development of computers, automation, and artificial intelligence, and this really helped us crack some hard problems in aerospace since then, like hypersonic vehicle and supersonic combustion ramjet engines. But really it provided the foundation for autonomous systems and drone technology. And another big thing that changed since then was, the development of aerospace projects shifted from big national government-sponsored programs to, private companies, small startups. Before 2008, before SpaceX put the Falcon 1 into orbit, people really didn't take startup organizations seriously in terms of, competing with legacy aerospace programs. And now SpaceX has the biggest market share for launch technology, and it is probably going to be the company that puts a person on Mars. And then most recently, and maybe not so visible, is countries around the world and smaller organizations are competing and leading in this aerospace innovation. And Canada is no exception. And we have, even here in Calgary, we have an impressive group of aerospace organizations. And we have educational institutions that are training the next generation of aerospace researchers, engineers, and we are doing cutting-edge research here. So with that, I would like to introduce our panel, a group of experts in aerospace from diverse backgrounds. So I'm going to start with Artem Korobenko. So Dr. Artem Korobenko is an associate professor here at the Department of Mechanical and Manufacturing Engineering. He's also associate head of research. He holds a research chair and leads the Computational Fluids and Structural Mechanics group. And his research focuses on the development of multi-fidelity computational methods for analysis and design of complex systems in aerospace, marine, and large-scale computing. He's also a Fulbright alumni and Alexander Van Humboldt Fellowship recipient, and he's a founding member and current president of the Canadian Association for Computational Science and Engineering. He's also a founding member and co-director of the University of Calgary Aerospace Network, and a co-founder and current director of the Aerospace Engineering Minor. So welcome, Artem.
Thanks.
Next, we have Linda Holden. So she is the dean of at the School of Transportation and School of Manufacturing and Automation at SAIT. And after working in the aviation industry as an aircraft maintenance engineer for 13 years, she returned to SAIT as an instructor and became the chair of their aviation programs in 2015. She was appointed Associate Dean of Aviation and Technology in 2019, and she holds a Bachelor of Technology and Leadership and Management from the Thompson Rivers University and is the past president of the National Training Association. She's also a board member of the Strategic Alberta Aviation Council, and she's currently finishing her Master's in Arts and Interdisciplinary Studies at the Royal Roads University. So welcome, Linda. And finally, we have Nima Najan, who is the Senior Director of the Innovation Hubs at Innovate Calgary. And he was the guiding mind in the creation of the Life Science Innovation Hub and Innovate Calgary's first accelerator. And he now applies that knowledge to drive the success of the other hubs, including the Aerospace Innovation Hub. And he brings over a decade of experience supporting startups and combining a unique understanding of the scientific and technical aspects of innovation with commercialization strategy and intellectual property knowledge. As a strong advocate of the Alberta startup ecosystem, he's been involved in numerous committees, including the Calgary Innovation Coalition, Health Cities, and various panels. Welcome, Nima. Okay, so I'm going to kick it off with some questions. So the first question, I'm going to start with Artem here. So why aerospace in Calgary?
Yeah, thanks, Craig, and thanks everyone for coming. And I think that's the question that many people probably have been asking. A few years ago, where there was a lot of news about the aerospace, and many of you still might be questioning why Calgary, because I think when people speak about the aerospace, they immediately think about the commercial aviation and they think about East. But I think, in short, we in Calgary, in Alberta, and in Western Canada pretty much has all of the ingredients to really push the next generation aerospace technologies. And by main ingredients, I mean something you already mentioned and Anders mentioned in his opening remarks. In my opinion, it's the three main components. One is you have the industry, which is emerging, which is has been here, for the last several years. The new industries is coming. Just to mention in few, of course, de Havilland was in the news recently, and then, before that we had the RTX here. We have a former Peraton here. we have Lockheed Martin, CDL, we have small companies like Atlantis Research Lab, UVAT, Canadian UAVs, etc. So that's one component. The second component is the access to the flight test ranges. So within the proximity of Calgary, you have at least two biggest flight ranges, which is the DRDC Suffield, you have a Cold Lake, you have the foremost US flight test range. Then the city of Calgary introduced several years ago the Living Lab initiatives, where you can come and test your small-scale UAVs over there. And the last component is as Craig mentioned, is the education. So here in Calgary, we have a very skilled students, motivated students who would like to work in the area. And then we have the experts in the field who has either past experience or the current project working with the leading aerospace industries, including DRDC, CSA, MDA, NASA, DLR, etc. So with all of that combined, I think we actually in the capacity to be the hub for the next generation aerospace technologies, in my opinion.
Maybe I could just add one more thing to that, and that's the actual source of innovations. And that's where we're looking at the University of Calgary, we're looking at SAIT, and other institutions within the province to try and spur the translation of innovation from research labs to the market. And I think we're really well poised to do that. There's a lot of great innovation and technology that's happening across the University of Calgary and other institutions in the city. So we want to really capitalize on that with all the resources and elements that Artem said to try and spur the ecosystem and grow it organically locally.
Linda, do you have any follow-up on that?
No, I think he covered everything, but we have a lot of things that are happening that we don't talk about. We're not really good at self-promotion in Alberta for some reason. But when you look at even the University of Calgary here, we have an aerospace minor now. That your geomatics program is renowned. There's a lot of drone work happening here. The Innovation Hub, the Intelligent Automation Research Lab. SAIT has the Alberta Aerospace Research Center. We have our Drone Research Center as well. We have our Advanced Manufacturing Lab. But there is a lot going on that very few of us know about, which is, I think a bit of a tragedy. But through these types of events, that's the best way to start promoting and letting everyone know the great things that are happening.
Just one more thing I forgot about, maybe one of the most important component is the leadership from the institutions, from SAIT, from University of Calgary, the leadership from the city. You have the Calgary Economic Development, who is really putting an effort in diversifying the local sectors. Of course, the support from the province and from the Western Canada. So, Prayers Canada is putting a lot of effort supporting, these I would not say new, but probably new to the Western Canada. And all of that really creates a very healthy ecosystem.
Maybe one more comment in terms of, sorry to interrupt.
You can't shut us up, apparently.
I think we talked a lot about what exists today, but I think the one thing that we need to work on as a group is access to capital, venture capital. In the city right now, there is a lot of money that's invested in lots of other sectors, traditionally in the oil and gas sector. What we need to do is unlock those dollars so that they can invest in the next up-and-coming companies, because without that private investment, it's really hard to grow those smaller companies. And we've been really good at attracting large companies to the city, which with it comes though that recognition that Calgary is a center for aerospace. But one of the next steps for us as a city, I think, is that unlocking that VC capital.
That's great. So I think this can follow into the next question. This one's for you, Nima. So how can the partnerships between engineering and other disciplines foster innovation solutions to the current industry challenges in aerospace?
So engineering and aerospace is inherently a multidisciplinary thing. Nothing ever works in isolation. But when you're thinking about translating that research, there's other elements that come in that may not necessarily be at the forefront of people's minds when they're doing research. And obviously that intersection between finance and risk analysis, at the end of the day, if you're translating something, it has to be commercially viable. And that means understanding the costs, understanding the risks, understanding the inflection points of the technology, and where that technology increases in value. And so that kind of financial modeling really has to go hand in hand I'm speaking to a room full of engineers, so you've probably already heard something like this, but I heard it more recently, so it was interesting to me. But there's a saying that goes, anyone can make a structure that can stand, but an engineer can make a structure that can barely stand. And really talking about that cost optimization, understanding where you can maybe give a little bit, where you really need to focus to create something that's safe, but also economically viable. So there is that strong intersection between finance. And then when you look at other things such as data, I mean, engineering and data are inextricably linked when it comes to AI, certainly from the analytical side, but more and more we're starting to see this intersection of AI and engineering where de novo prototyping and development is being done using AI, and NASA's already doing this on their next, forgot the name of the exact mission, but they've developed scaffolding as a support for their next space mission. So it's already being employed, and it's certainly going to, I'm not going to use the word explode, but grow really quickly in the next little bit. And so I think those kinds of interdisciplinary aspects to developing technologies and doing research are just going to become more and more important, and that intersection between multiple disciplines is going to be essential.
And how does the panel feel about the collaborations between industry, academia, and government for achieving these innovations? Maybe Linda, do you have thoughts on that?
Well, that's the secret sauce, right? Is having that integration where we blur the lines between post-secondary and industry. Like we exist, when I speak of we, I mean post-secondaries. We exist to, and I'm going to kind of bleed into my next question here, if that's okay. But when you talk about a workforce, a skilled workforce, I think about an ecosystem. And you have different components in that ecosystem. You have the research, the scientists, the engineers, in one area, and then in the middle you've got the technologists, and then on the other end you've got the trades, right? And so in order for that ecosystem to work perfectly, everyone has their strengths and their technical abilities and competencies, but there's commonalities of competencies across that ecosystem. And I engage with industry quite a bit. And I hear the same thing. We need better communication. We want them to be better project management. We want them to be able to work in teams and collaborate. And that's a common theme across the workforce ecosystem that we're seeing. And so that's why it's important for us to constantly be engaged with industry, because we need to know what they want. They don't know what they want yet. Sometimes we can tell them what's coming through our research, especially universities like U of C, U of A, large research centers. That's so important when you're building an ecosystem too. And when you're building the workforce to support that ecosystem, we need to be engaged lockstep with industry. So, yeah.
Do you want to add, Artem?
Yeah, maybe just a few things that also related to my first point, what Linda said about the ecosystem. But I think it's important to mention, when we look at the developments, you have a TRL 1 to 10. Right? And let's say industry is interested pretty much, which is, market ready. But everything starts with the scientific breakthrough, right? You need to go through that fundamental development. And this is where, industry can come up with a challenge, which we can address as the post-secondary institution. And then in addition to a practical application, we have a scientific knowledge that we generate, right? And I think Canada in general has this very unique ecosystem to provide opportunity for the industry-academia collaboration through the matching funding. Let's say there are lots of industry in this room who may not be familiar with this opportunity. You can put $1 and government can match it 2 to 1. And then you go to the province, you can further match it 1 to 1. And then you get your tax credit on top of that. So at the end of the day, you can actually get a 5 to 1 matching, and you get a high-skilled professionals who are tailored and trained specifically to your need. And then when you want to hire those people afterwards, there is another opportunity in Alberta where they can provide additional matching to that. And so with all of that combined, I think we are well positioned. That's something which is not existing anywhere in the North America. Like in the US, you have like SBR, right, which is program like that. But funding like this is not available. And so I think we should, make use of that opportunity. And one thing I actually want to mention in my first point is that aerospace is not only a new development. Lots of traditional industries, speaking about Alberta, it's like oil and gas and agriculture, they are benefiting from these new developments. Unmanned vehicle is one of that, right? But there is a way more where, not only the new developments can show up, but the traditional industries can be, on the cutting edge of that. So.
Great. So Linda, this question's for you. This is more an application of aerospace, the airline industry. So what can airlines do to help reduce their carbon footprint?
Great question, and that one gets thrown around quite a bit. So there's a few things. So it's all about weight, right? The lighter we can make our aircraft, the more efficient, the less emissions. We can also talk about operational efficiencies around load factors, making sure our airplanes are full and they're not flying half full. We can talk about leveraging generative AI in terms of manufacturing processes. I read an article, this was a while ago, this is 2018 already, where Autodesk and Airbus partnered and manufactured some internal bulkheads and manufactured them so they were half the weight. So there's, I think, but, some of the, I guess, the barriers around making aircraft more lightweight and using advanced materials is the certification process around that. So this is very labor intensive, as the de Havilland folks sitting up front here know very well, that this isn't an overnight prototype, into market type of process. It's lengthy and it's costly. And then there's the SAF, the Sustainable Aviation Fuel play there. Now, it's not easy to say, yes, we should just use more SAF. You have to have good supply of feedstock being canola, soybean, tallow. There's different types of feedstock. So the way we make SAF is that we take feedstock, we create sustainable aviation fuel, and we mix it with Jet A or another Jet A, typically. And then we need the infrastructure to create the sustainable aviation fuel. We need the infrastructure pipelines to deliver that fuel to airports. And then we need to incentivize airlines to buy the fuel, because that fuel is more expensive right now than it is to just fill up with Jet A. So there's a lot of, again, challenges around SAF. There's a lot of challenges around adaptation of lighter materials, advanced materials, because of the certification process. But these are all areas that we can look at and start dealing with. So at some point we need to start, right? And I think that has started and it will continue. So we will see some lower emissions come out of all of these initiatives. But it's not a one thing solution. It's going to be a lot of little things that airlines will do to adopt and become more efficient. But yeah, and it's going to be a process. It's going to take time.
Nima, did you want to add your thoughts on the sustainable aviation fuel?
Sure, yeah. I mean, flight is inherently inefficient. It is the least efficient way you can travel. So anywhere there is an ability to make some savings and increase that efficiency is always appreciated. And there's lots of up-and-coming technologies, battery-powered airplanes, hydrogen. None of those are quite ready because they just don't have the energy density. Whereas sustainable aviation fuels is here today. In fact, it was just last year, or just over a year ago now, that Virgin did the first transatlantic flight with 100% sustainable aviation fuel from London to New York. So that technology exists today, but the barriers holding it back are essentially cost. Mm-hmm. Right now, SAF is 2 to 9 times more expensive than traditional aviation fuels. And there are not a lot of margins in the airline industry. So when the margins are that low, you can't increase your fuel costs by even 2 times. So what we need to do is develop technologies that will lower the cost of developing these kinds of fuels. At the same time, develop engines that are going to be more compatible with these, and maybe it's not 100% SAF, but some combination, mixing it with Jet A or something that makes it more compatible. But going back to that whole transdisciplinary thing, it's going to be the people developing new crops that are more amenable to SAFs, mm-hmm. developing the SAFs and refining it, and then ultimately developing new engines that are going to be compatible with these kinds of fuels.
And just to add about the new engines, like there's been some significant advancements in turbofan, geared turbofan engine efficiencies, like almost 20% reduction of emissions in these new turbofan engines that are coming out from GE and LEAP Safran engines. So it's coming, it's happening, and yeah, stay tuned.
And maybe just one more thing to add, when we speak about sustainability, it's not just the fuel, right? Because we actually have to look at the whole sustainable manufacturing, at the whole process, right? To assemble the parts. And so many people may think, oh, I'm not fitting sustainability aspect because I'm not working on the sustainable field. But if, you are a manufacturer and you are implementing the sustainability aspect in your manufacturing, you are addressing that need because, yeah, you can reduce the emission from the field, but if your whole manufacturing process is not sustainable, then, at the end, you're not really reducing anything. So you have to look at the process as the whole. Yeah.
Okay, this next question is for you, Artem. What do you think the next big advances in aerospace will be?
Yeah, as you mentioned, we are on the peak of the next, boom, right? And probably, in my observation, I would identify the two main areas, which is the high-speed technologies, which is the supersonic and the hypersonic, and the autonomous and unmanned vehicle. So I will speak about the first part, and let the rest to maybe comment on the second. And so I am heavily involved in working with high-speed technologies. When we speak about the supersonic, it's like you're flying higher than the speed of sound, and hypersonic, you're flying 5 times higher than the speed of sound. And when people hear about those high speeds, they always think about the military application, which is it's one aspect, but these days, actually, what is booming is to implement the high-speed technology for the commercial airlines, right? Because you want to fly from London to New York in few hours, right? So there are lots of companies who are trying to bring the hypersonic airliner, which has lots of challenges, from the fuel consumptions, from the, sounds, from the stability, from the material point of view. Then Craig mentioned in his opening remark the Concorde, right? The Concorde was phased out because of the noise emission. And so there is a program right now going on between NASA and Lockheed Martin on the low boom shock demonstration technology, where pretty much they actually already flight tested a vehicle, I think it's XQ-59, right? And they actually showed that they reduced significantly the noise emission. So, reducing the noise, it's one, and then just producing an aircraft that, can be stable and reliable at that regime. And then from the engine point of view, right, there is recent news from Pratt & Whitney and RTX where they tested rotation detonation engine, right, which has no moving part and it can go all the way as the ramjet to scramjet regime, right? And, it's like a shock waves that keep traveling, right? So there is a lower fuel consumption, there is no moving part, and, that type of the breakthrough where I think we as the city has a lot of expertise and lots of collaboration going on with NASA, with MDA, CSA, and researchers across the world, right? Because we are, well positioned and, people aware about the activities that's going on. We are part of the various NATO working groups, so we all have lots of, technology and high tech.
Yeah.
Wait, just before Linda and Nima add their 2 cents here, so we're going to go to questions in a bit. So after your comments here, we'll just circulate the microphone and the audience can ask questions.
Is that, hurry up?
So it would be some brief responses.
Okay, I will keep it brief. But there's so much to say. This is almost a panel in itself when we talk about drone and unmanned systems. So much going on in the Alberta ecosystem around drones, especially in a commercial sense. Like a lot of oil and gas companies now are realizing the financial advantage and savings that they can leverage by using drones for inspections. A lot of non-destructive testing use drones now, where so there's no need for scaffolding on big infrastructure projects when they're looking for asset integrity. I read a stat, this was 2020, again, it's old. It's around 50 to 60% of the drone companies were in Alberta, like Canadian. So we have a very strong drone ecosystem. so much going on too in the military in terms of development around drones, and they're using Calgary-based companies to develop that, help them develop that. A lot of detect and avoid systems that are being tested, like ArcFil was part of that as well. So there's so much going on. Like I said, I think it's like next month's panel or just to do an unmanned air systems. We have a lot of testing centers too. We've mentioned Foremost already. SAID has the Cirrus Lab, which is a center for unmanned drones as well and research. We have the first BV Loss Training Center, which is beyond visual line of sight. What else can I think I'm done. So, yeah. Out of time.
So Nima, you can have the last word before questions.
I don't want to add too much because they did an excellent job of covering it, but I do want to pick up on one thing that Linda said about her 2020 data being old. We're talking 5 years old, and yet the industry is moving so quickly that that's already considered out of date. So it just kind of puts things in perspective of how fast we're moving.
Excellent. Okay, so if anyone from the audience has any questions, please make yourself known and ask. Go ahead.
Hi, Vanessa White from Alberta Innovates. We're currently in the process of doing our strategic plan, and aerospace is something that's showing up as a new innovation opportunity for us. And curious around your perspectives on the reality of a hydrogen international overseas flight.
I can open up just quickly. As was mentioned, yeah, that's one of the alternative field, but there are challenges. You know, the storage of the hydrogen, that's one challenge. You know, that the transfer of the hydrogen, that's another one. And actually use that as the field itself provide, you know, from the combustion point of view, right, from the simulation, you know, just analysis of that. So we have lots of projects going on actually in the University of Calgary related to the hydrogen, and I would even say they're like a dual use, right? So pretty much the development would be directly applicable to the aerospace industries.
There's so much going on. Who's going to win the race, right? Like, is it nuclear? Is it hydrogen? Is it electrification? Maybe there's something else we haven't even discovered yet, right? And it's constantly moving. Yeah, I know the barriers around certification. So I think we need to start having maybe government entities that are more willing to, I don't want to say take risks, because you don't want to do that in aerospace and aviation, but maybe are willing to work with our research and industry partners to try and accelerate certification around new technologies. But yeah, which one? Hydrogen, that's still, I think, too much of an unknown around aerospace and aviation. But definitely, people are looking at it, and people are trying. You know, people are trying to innovate and look at what the next, what's the next energy source, right?
Yeah, I think from my perspective, hydrogen, from the energy density perspective, is going to be a challenge on long-haul flights. Maybe for short-haul flights, it could be effective. And the reality is most of the flights are short-haul anyway. So it could be a potential future technology, but it's not ready for prime time today, and it's going to require a lot of development, and a lot of the challenges that Artem highlighted are going to have to be overcome before it can actually be used in a commercial setting.
Any other questions?
Richard Dunn here. I'm wondering, with the trade disputes and really the rise in protectionism, with the U.S. protectionism, how that affects the Alberta's aerospace interests and what the responses are.
There's just so many unknowns with the tariffs right now, and they change from day to day, that I don't think anyone has a clear understanding of how anything is going to be impacted. Yes? For sure. I mean, I think we've already seen the fallout of that from the travel perspective. A lot of Canadians are choosing not to travel to the US, and a lot of American tourism comes from Canada. And that's not really because they put a tariff on travelers, it's because it's more of an ideological thing. So there are obvious economic impacts that will change the way we do business, the things that we buy. And from a manufacturing perspective, obviously a tax on steel and things like that will impact manufacturing. But Canadians as a whole have stepped up, and it's actually spurred a new sense of nationalism amongst ourselves to say, look, we don't want to be treated like this. We're making choices in the things that we buy. We're making choices in the places that we go. And I think that ultimately is going to have a negative impact on the US economy. It will obviously have a negative impact on the Canadian economy as well. It's going to hurt. But the reality is, I'm personally impressed with how Canadians have stepped up to this challenge, and we're banding together and trying to address it in a way that hopefully in the long run we'll see things through.
And if I can just add, aerospace is a global industry, so which is a good thing because we can look to different markets to sell our product. And so I think that's the biggest differentiator maybe between aerospace and maybe other manufacturing. Let's say automotive would be a good comparator, maybe. Automotive, they kind of have their one customer, the US, versus aerospace. The world is our next customer.
Maybe just quickly to add, I think, so Craig mentioned the Avro Air, right? We used to be at the, the forefront of the, aerospace technology. And I think with these tariffs and the whole situation, that actually mobilize, the internal and local community in terms of industry, in terms of the researcher, and in terms of government to revisiting, where do they put the emphasis? Probably they would then provide more support to support this kind of developments, right? So again, still, as Linda mentioned, we have lots of international companies who have a presence here. We have, ITB technology, right, where that can be used as the mechanism for, mobilize the local SMEs, the local post-secondary institutions, and the governmental agencies.
Thank you and good morning. Ali Mohammadi here from University of Calgary. I have two questions. So first is with regards to basically manufacturing and research and development side. My understanding is that here in Alberta, for example, the plant of Pratt & Whitney in Lethbridge or basically the de Havilland that recently opened, they're focused on manufacturing. Are we doing anything with regards to research and development here? And the second question is that basically, are we planning to basically collaborate with other provinces, or are we basically deciding to have it as like an Alberta-based thing as we're developing it?
I can start with that, maybe because I'm a professor from a mechanical and manufacturing engineering department. So that's, I think, answer part of your questions in terms of do we have research, going on in that area? We do. So we have lots of professors working on, additive manufacturing, introducing the, cyber technology into manufacturing, right? The robotics, etc. It used to be Industry 4.0, I believe. Now we're in the Industry 5.0, right? 6.0, right? So, we keep outdated as we speak. So in terms of collaboration with other provinces and internationally, as Linda correctly mentioned, manufacturing is the global, right, thing. You could not just, localize. I mean, you will have a specific capacity, a specific need, especially if you have an industry which is local. So they need it pretty much right now, right? But there is some expertise where we can, benefit from collaboration, and that's again where the federal agencies come into place, and the provincial agreements, and the Prayers Canada and other who will support that type of collaboration.
Yeah, I would say manufacturing is great. It definitely creates a lot of jobs and boosts the economy, but the economies that are the strongest are not always centered around manufacturing, but more centered around technology and innovation. And I think there's a lot coming out from the post-secondaries here. And more companies are looking to the post-secondaries for that pipeline of innovation and technology. The research happens at the university. If it's commercially viable or has commercial potential, then the companies look, okay, how can we take this idea, maybe even just a research paper, and turn it into an actual product or incorporate it into a product? And that's where the innovation is really driven by the universities. And oftentimes the technology is not quite ready to go directly into a company, like a larger company that's going to incorporate it into their product. And what we're trying to spur now here in the city is to encourage academics, their students, their postdocs, to create these startup companies that take the technology, do that product development, that early stage product development that doesn't really belong in a university setting because it doesn't result in sexy papers, no grad student really wants to work on it, but it's essential to take that idea and develop it a little bit more so that it's more appealing to a company that might actually want to incorporate it into the technologies that they have.
And if I can address your interprovincial collaboration, so we are starting to talk to Aero Montreal. So Aero Montreal has done, when I say the gold standard around creating an aerospace ecosystem, that's who you want to look to benchmark yourself. They are doing, so they committed to investing in aerospace about 20 years ago, and it's paid off. They have some large primes there. They are continuing to innovate. Their strategy now for the next 5 years is around air mobility as well. So you'll see them, because they're intentional and they have the will, they will be successful. And so I think if from an Alberta advantage point of view is that we need to start getting a plan together, a strategic plan, and saying, this is what we're going to do in the next 10 years in aerospace in Alberta. And I don't think that exists yet. And until that exists, and we don't see the will of the province and the focused efforts, I think we're not going to be as successful as we can be, because we have so much potential, but we're just missing the plan and the will. Yeah.
So I think that's a perfect spot to end this Q&A, and thank you so much to the panel members for coming here and talking about aerospace, and I'll pass it back to Anders for the final remarks.
All right, thank you, Craig, and I'll add my thanks to the whole panel. So thank you, Craig, thank you, Artem, Nima, and Linda for your contributions on the panel discussion this morning. And many thanks to all of you in attendance for taking part of your morning to spend with us here at Schulich Connects. We hope you will join us for our next Schulich Connects. So on April 24th, we will have our next event. It will be entitled Engineering Outside the Box, the Power of Cognitive Diversity. So hope to see you all there. Keep an eye on the inbox for the invitation to that next event. And until then, thank you again. Wish you a great rest of your day, and hope to see you again soon. Thank you very much.
Thanks for tuning in to this Schulich Connects. We'll see you next time.